Hello, in this video we'll understand how to find the nth derivative of ln ax plus b. So if the function is given to us as y is equal to ln ax plus b, first we'll start with finding the first derivative of this. So first derivative can be written as y prime, or it also can be written as dy over dx. Now we know that the derivative of ln x is equal to 1 over x. So we are going to use this concept to find the derivative. So the derivative of this function is 1 over ax plus b, and that being multiplied by the derivative of ax plus b. So we are applying the chain rule. So multiplied by derivative of ax plus b is just a. So this is our first derivative. Now, to get the second derivative, I can consider this as being ax plus b raised to the power of -1, and that being multiplied by a. So for that, the derivative of this function, we'll use the power rule, which means -1 being multiplied by ax plus b raised to the power -1 subtract 1, which gives us -2, multiplied by a, which was already there, and it is going to be multiplied by the derivative of, again, this function inside. So this is another a in multiplication, which gives us a square. Now for the third derivative, this is going to be equal to -1 times -2. So what we'll do is the -1 we'll multiply over here, and we'll make it -1 raised to the power of 2, and that being multiplied by 2, it's the same thing, but it will make it easier for us to get the nth derivative, being multiplied by ax plus b raised to power -3. So this is the power rule we've applied. And next, now applying the chain rule, we'll multiply it by a. So a multiplied by a square gives us a cubed. Now we'll find one more derivative, the fourth derivative, and get to the nth derivative. So now to get the fourth derivative, this is again -3 will come here in multiplication, because that's what the power rule says. So we are going to apply -1 being multiplied by this -1. So this gives us -1 raised to the power 3. And now this 3 comes in multiplication with 2. So 3 times 2. And then ax plus b raised to the power of -4. And then multiplied by the derivative of this. So multiplied by a, but we already have a cube over here. So this becomes a to the power 4. Now let us generalize the nth derivative. So when it was the second derivative, -1 was raised to the power 1. When it was third derivative, -1 raised to the power 2. For the fourth derivative, -1 raised to the power 3. So for nth derivative is going to be -1 raised to the power n minus 1. It's one number less than 4. That's the exponent of -1. So we can see when it is the fourth derivative, it's 3 factorial. When it is third derivative, it is 2 factorial. When it is second derivative, because nothing is there, it's multiplied by a 1, so it's 1 factorial. So for nth derivative, it is going to be n minus 1 factorial. Now, the term ax plus b to the exponent of -2 for the second derivative, exponent -3 for the third derivative. So for the nth derivative, it is going to be ax plus b raised to the exponent of -n. And the same thing for the exponent of a. For the fourth derivative, the exponent of a is 4. Third derivative, exponent of a is 3. So for the nth derivative, exponent of a is going to be n. So if you don't want to leave the negative exponent, this is going to be negative 1 raised to the power n minus 1, n minus 1 factorial. To make the exponent positive, this is going to be 1 over ax plus b raised to the exponent n and multiplied by a to the exponent n. So this is our generalized nth derivative of ln ax plus b. I hope you understood the process. See you in the next one. Bye-bye.